yesterday we said something as interrupt in service flag. You remember? Interrupt in service flag. For that, like we have the which are restricted. Balaji, Kupusali. In IE register, ET0 is there. Whether that is the interrupt flag, in IE register there is a ET0, EX0, EX1, ET1, ES. Are they interrupt enable flags? Not interrupt flags. So IE register will just give you a interrupt enable flag. Interrupt in service flags are TF0, TF1, TI, RI, IE1. These are interrupt enable flags. Sorry, interrupt in service flags. Whenever there is an interrupt occurs, this will be 1. Whenever your RETI works, whenever your processor or controller encounters this instruction, it will clear this flag. Right? We have written interrupt in service flag, about that 1-2 sentence. You write these are the flags. These are. For each of this one to enable, we have ET0, ET1. For both of this, we have only one flag called as ES. For this, we have EX0, EX1. These are interrupt enable flags. For all of this, there is one master, EA. Did you got a difference? These are the interrupt flags. These are interrupt enable flags. We are just enabling these interrupts through this. TF0, how do you handle? Guys, listen. Keep the door open. Keep the door open. How do you handle this flag? This flag will rise anyway. If it is overflow, it will rise anyway. If there is no interrupt, ALU should check this using jump on no bit or jump on bit. Remember this instruction. If it is interrupt enabled, then the way in which we are handling it is different. Basically, they are there. We have not enabled it. We have enabled it using an IE register, and the way in which we are working with them gets different. That's all. Did you got it? This is a very, very basic point. Right? I hope it is clear. These are interrupt flags. These are interrupt enable flags. They are there already in your system. The way in which you handle them is different. Using JNB instruction for TF0. Even for TI and this we did the same, right? JNB instruction only. Right? Same instruction. So using JNB we used to poll every time. For every 2 machine cycle once, ALU goes and checks whether that is enabled or not. If it is not enabled, do something else. If it is enabled, do other thing. That method was polling. Now like once it rises, now as I have enabled, TF will take your PC directly to 0013. 13 or B? B. 0B. If TF rises, PC will directly go there. You don't need to do that polling now. Is it clear? This is very, very fundamental phenomena. They are there. It is not enabled. We have enabled it. Meaning that like whenever it is set, TF0 is set, PC will change its value by itself. Is it clear? Right? Done. Second point. Yesterday we said like timer move T0, TL0 for mode, sorry, reverse. For mode 2, actually we put a value to only to TF0. and some value we have put, BB we have put, yesterday I remember it. Right? Then like whenever we say like start bit, set bit TR0, this will happen by itself. It is not required. But if you write, there is nothing wrong. You are understanding a point? In mode 2, you need to put a value to only TF0. When you set bit TR0, when you do this first time, this gets copied to TL0 by itself. There is no need to do this explicitly. But if you do it also, there is nothing wrong. Is it clear? Once again, it will happen. Yesterday we had this point. Is it clear? Right? Done. Now we will go to serial interrupt. Shall we write these things? This one sentence, you please write it. Interrupt in service flags. Interrupt in service flags. Or interrupt flags. It is one and the same. Or interrupt flags. What do you mean by, what is the difference? Interrupt flag and interrupt in service flag. Interrupt flags are all together, they are interrupt flags. Interrupt has been raised. That flag will become interrupt in service. Okay. Interrupt in service flags are TF0, TF1, IE0, IE1, TI and RI. They are already there We have just enabled them using IE register. Using IE register. Whatever the order you have written, TF0, TE0, you have to write the same thing. ET0, using IE register in bracket ET0, ET1, EX0, EX1. Correct, right? We have taken RITI, we have taken at the end. RITI, we have taken at the end. RITI together it is one ES. So that we can handle them in interrupt mode rather than polling mode. So that we can handle them in the interrupt mode rather than polling mode. Clear? Right. So timer mode will not write. It is not connected to this, but it's just a reminder that we have studied it already. Yeah. Is there anything that I have missed out? No, right. Okay. So serial interrupt. Serial interrupt, the simple phenomena is for Ri and Tri together, it is given to an OR gate whether Ri rises or Ti rises, serial interrupt will rise. It is your responsibility to check whether Ti has rise. What is the address for this serial interrupt, vector interrupt table address? This serial interrupt is not there. Guys, listen. Hello. SI flag is not there anywhere. It is only for our study, saying that these two together constitute a serial interrupt. If you ask me where is this bit, it is not there in the anywhere. Only these two bits are there. What is the IVT address? Interrupt vector table address? 23. 0, 0. Whenever this interrupt rises, your PC value will be 0, 0, 2, 3. Whenever Ti or Ri rises, value will be 0, 0, 2, 3. Okay. Now the question, for what you need an interrupt? For Ti or Ri? Which is predictable, which is not predictable? Ti is not predictable. Huh? Ti is not predictable. Both are not predictable. Now, there are some interrupts which can be predicted, like timer interrupts. 100% we can predict when the timer interrupts will occur. But we cannot predict when the external interrupt will occur. Not possible. Ri or Ti? Quickly. How many Ti? Ti is not predictable. Only 3. Why do you think Ti is not predictable? Any time? No, Ti flag is when you transfer a data. When you transfer a data. Yeah, when you transfer data, you know the Ti flag rises. But somebody else transfers the data, you don't know when they will transfer. You're getting what I'm saying, right? You are ready to receive. But that fellow has to send. He can send now, he can send later at different time intervals. We don't know when he will send. It will go high. Then we have to read from SBUF to A. So 99.99% serial interrupt flag is connected with Ri. However, you need to check it first. So please mention that also. Mostly, serial interrupt flag is attached to Ri. Clear? Now what we'll do, we'll write one small program. What is the program? Okay, listen now. There is one 8051. Okay. Which has port 0. For port 0, what I do, I will put one keypad. Now, whatever I type here, it will get inside it, provided this you make it as an input port. It is ready to receive. Whatever I type here, it will go in here. Once the data is here, I will have to send this data on the serial communication. Serial communication, this is attached with SBUF, right? To some other device. Maybe this device might be another 8051 or your display board. Somebody wanted a display board. Display board will be enabled with the UART protocol. What UART protocol means what? There has to be a RI flag, TI flag, baud setting register. If that is there, then there is a UART protocol is there. You are getting what I am saying? A display, or it might be a communication device. Like your GSM modem or Wi-Fi modem or like some RF tools or wired communication. It can be anything. Some communication device. From here it will go to the another device. Then like it will receive, that will transmit and this will receive and send. You are getting what I am saying? Right. So this device can be anything. Let's now assume like it is a display. We'll assume it is a display. So, not display, 8051 only. Another 8051. Another 805. 23 if I type. That 23 has to be sent to SBUF. From here it has to be sent to another 8051. This is a continuous process. What I have to do? Read from the port 0, put it to A to SBUF continuously. Do this continuously. Okay. When I am doing this, whenever there is a data sent from 8051, you should also read that. Transmitting continuously. In case the data back, saying that like I have received some other data, you should also read that. This is TX, this is RX. So when you receive the data, your RI flag will rise here. Whenever there is RI flag, instead of putting a value from A to SBUF, you have to read from SBUF to A. Then like send A to port, some other port 2. We'll say there is a display here, R display is here. Getting what I'm saying? This is a program that we should write. What is that? Whenever I type it, it has to be sent to SBUF, it has to be sent to another 8051 through the serial port, serial communication. This is in continuous process, or this is in infinite loop. In the same process, whenever this 8051 replies, we should also read that. When it sends back, the RI flag will be high. When RI flag is high, instead of sending A to SBUF, I have to read from SBUF to A. That A value has to put to the P2 and display it on. Say the display connected, we will not worry about this one. From A to P2, that's all. Clear with the requirement? Clear with the requirement? Now write the program. Any doubt in this? How do we write a program? What is the first step? ORG00H. Next, ljump to main. Next, what should I do? Okay, after this, like I need to write for ORG. What is the address for this? 0023H. I should write some code here. After that code, like I have to go to main. Shall I write it here? Okay, we'll write here. What should be there in main? Main I will write it at ORG some 30H. We'll say around 100. What should I have to write in main? First thing, what should I write? IE register. What is the IE register value? What is the IE register value? EA, reserved bit. Next. EA, reserved bit. Next. ES. Next. EX0, ET0. Oh, ET2 is here. Before ES. This is not there. This is also there. ET2, ES, ET1, EX1, ET enable this and then enable this. The remaining are all 0. Correct? Let's see. We'll write it accordingly and then we'll find out like what is, if there is any mistake. What is the number now? 9, 0. So move. This move is visible from last bench. Move IE, hash 90H, hash 9. Okay, let it be. Done. So serial interrupt I have enabled. Next, what should I do? Next, what should I do? Quickly. All of you have written serial communication program. All of you have written serial communication program. Okay. So what is that you have done in the serial communication program? Baud rate. Where is the baud rate that you are setting? T mod. Yeah, I had write a value for T. Next I will set for move T mod. What value? 520. If I write 20, what happens? T mod equal to 20H. Why 20? When it is 20, Okay, tell me the T-mod register. T-mod. Huh? T8. Gate. Okay, gate. Gate. Over. T-mod register. Okay, I remember now. M1 gate C by T M1 M0. This is a repeating now. If you say 2, it will become what? 0, 0, 1, 0, 0, 0, 0, 0. That means you are operating timer 1 in mode 2. Timer 1 in mode 2. Right? Why is that? You are operating timer 1 in mode 2. Mode 2. Auto reload mode. Sorry. Timer 1 in auto reload mode. Timer 0. Hello. There is a SCON register wherein which you should set a value for serial communication. In that, we'll see what is SCON register. Let me know the SCON register thing. SM0, SM1, SM2, REN, 8, RB8, yeah, I remember, TI and RI. This is a SCON register. This is T-mod. This is IE register. Now, what should be the value to SCON for serial communication? 50. Why 50? If I put 50, what happens? 0, 1, 0, 1, 0, 0, 0, 0. These two flags will rise when you are transmitting or receiving. Don't worry about this. RB8, TB8 are not used in use, so don't worry about them. REN is what? By transmission, it will be there always. If you want to receive data, you should enable it here. So this is receive enable. SM2, what is SM2? It is not there in your, don't worry about this bit. It is a multiprocessor mode, which is not there in your syllabus. SM0 and SM1, these are the modes. If it is 00, what is the mode? 8-bit shift register mode, 01. Only this mode is there in your syllabus. Only this mode is there in your syllabus. Bit and one start bit. Who will set the baud rate when I set this? For mode 1, which timer? Timer 1. That is why I am doing this timer 1 here. Got point? Should link these things. I have told this always. Microcontroller is not a subject to be studied an individual topic. It is all linked. If you cannot link, you cannot answer the question. If you are mugged up, like you can answer only for that. If we twist, gone. Right? So that is how we are making T-mod 20 now. Why it is so? Because when I set this mode 1, the mode 1 baud rate is decided by timer 1. We have given this, right? Mode 1 baud rate is decided by timer 1. Mode 0 baud rate is decided by crystal frequency. Is it correct? Yeah. For 2 it is 2 modes, it is a crystal frequency. For 2 modes it is a... Is it clear? So what I do now in here, timer 1 mode 2. Okay, done. So T-mod I have set it. Next what should I do? T-mod is in timer 1 mode 2 auto reload mode. Next what should I do? Complete this, then we'll go to SCON. Move TH1 comma -3 or FD. It's one and the same. -3 for what? 9600 baud rate, it is FD. So it is -3. We have discussed this -3 FD concept we have discussed. Next what should I do? So in this case now baud rate is set. Timer 1 is selected, baud rate is set. This is enabled, done. Next, what should I do? SCON. Move S50H. It is semester, present semester, SCON will always be 50. What is next? So we have set SCON, everything we have set now, almost ready. Yes, we have set everything. Serial communication is ready. Interrupt is enabled. Baud rate is ready. Next, what should I do? Start. Timer. Start a timer. Set bit TR1. Timer started. So baud rate started now. Now next what? First thing you listen. Though port 0 is already input port, I will still suggest you make once again this pin as an input pin or this port as an input port. How do you do that? Whole port you should do. Move P0 comma hash 0FFH. This is to make this pin, though it is there already. When you reset it, will by default it will be there. Still it is suggested to do this. Only precautionary method. Now all setting is done. Next, what should I do? And this setting has to be done only once. Next, what should I do? Move the value from A to SBUF. From where is the value that you get to? So what I do is move A comma port 0, move SBUF comma A, SBUF comma A, then from P0 I have taken a value to A, from A I have put it to SBUF. Next, what should I do? When interrupt rises, transfer interrupt rises, will come here, we'll handle it here. Next, what should I do? Loop. Yes, jump. Loop. Keep doing this. Read data from there, push it. Read data from there, push it. Keep doing this infinitely. Next, what I should do? Shall I rub this T, SCON and this one? Your biggest task is to remember this. Difficult thing. For me it is a difficult, I don't know how do you handle. This register value. Okay, SCON. Remembering the procedure is very important. That should go by default. If you are working on a serial communication, first thing that should come to your mind is set SCON register. If you are working on the timer, first thing that should come in your mind is set TMOD and TCON. Right? Similarly, once you set a SCON, then you should know what are you setting. Once you know this, then you can do this. It should actually be SCON first and TMOD and TH0 next, TH1 next. It has to be this. Then you are working on interrupt, then this one. Clear? Right, next. Next, what should I do? Okay. After 0, 2, 3, this is the last interrupt, right here. But it is suggested, if it is, your code is only 8 bytes, you write it here. Otherwise, you jump to some other location and write it. So for every interrupt, approximately 8 bytes are reserved except RST. Reset. For reset, you have only 2 bytes. 2 bytes, right? 3 bytes. Only 3 bytes are there for reset. Apart from that, all interrupts have 8 bytes of ISR space. If your code is more than 8 bytes, write an LJump, go to some other location, 100, 200, 300, write your code there. Okay. What should I do here? This is all. This all is your code. I will just say end. Next, what should I do? First step, what should I do? Once this is I have written, it is transferring data continuously, right? First thing what happens, TI flag keeps coming. Because I am transferring it, I will transfer 23 Last bit of 23, when it is leaving, it will rises Ti and goes. That means like the next bit. But Ti has one this thing here. Yeah, this is a problem. Interrupt in service flags, RETI, we said like interrupt in service flags will clear, RETI will clear all interrupt in service flags. But it will not clear RI and TI. Because it does not know whether it has been, interrupt has been called from TI or RI. It does not know to which to clear now. So these flags, though they are entered manually. Is it clear? Right? Done. Now, first thing, what do you have to do here? What do you have to do here? Next, first thing. Okay, I will give you the structure. Jump on bit TI to what is it? Should I write? Transmit. Trans. Right? To trans. I will write trans here. TI, right? Just say CLR TI and RETI. Clear that interrupt, because that interrupt has right when the data is sent. Now you don't need to do anything. Just like clear that interrupt, go back. If it is not there, jump on bit trans, like it will go here. If it is not there, it will come to next instruction. What should I write here? What should I write here? If it is not TI, it is RI. Only two options are there. Next. Move A comma S buff. Next. Move P2 comma A. Next. CLR RI. Clear RI. Next. RETI. This is a standard structure. Now the question is how many bytes it will take. Don't write it once again, hold on. This is 2 bytes, this is 1 byte, this is 1 byte, this is 1 byte, this is 2 bytes, this is 1 byte, this is 2 bytes. Is it more than 8? Then you cannot write it here. So what you need to do is, do this as 100 we have written there. Take 200 H here, right here. Give this. Guys, listen, don't write. Then here ORG 0023H, you just write L jump to serial. You understood this? You understood this? So whenever interrupt rises, it will come here. Whenever it comes here, it says L jump to serial. Serial, it jumps from here and starts. As it was more than 8 bytes, I have known it. Where? Means? P02 S buff, yeah, it will happen very fast here. Whenever there is jump on bit TI to that. What are you saying? No, your point is right. What you are saying is, here I should use jump on bit TI to loop. Correct? That is what you are saying. Yeah, that is also right. That will be more authenticated. This is simply we are taking a data and pushing it. We are not worried about like whether it is the same data or whether it is a new data. You have pressed now. That will be stored in the port latch. It will take that and push it. Take that and push it. Even if it is, you are not giving a new value, it will still read 23 and push it. Yeah, it will do the unnecessary job. Any doubt in this? This is very important. One serial program which is very standard. ಏನು ಆಗಲ್ಲ ಅಂತ ಹೇಳಿದಲ್ಲ ಅದು ಬರಿಬೇಕು ಲಾಸ್ಟ್ ಇದ ದಿಸ್ ಮೇನ್ ಪಾರ್ಟ್ ಐ ಹ್ಯಾವ್ ಅಂಡ್ ದೆನ್ ಲೈಕ್ ಐ ಹ್ಯಾವ್ ಲಾಸ್ಟ್ ಇಟ್ ದೇರ್ don't know when I will improve writing on the board. Any doubt? Is any doubt? Is it clear? Right. After this, write up below one statement. Though RI and TI are interrupt in service flags, though RI and TI are interrupt in service flags, RETI will not be able to clear though RI and TI are interrupt in service flags. Chetan, are you writing what I am saying? Though RI and TI are interrupt in service flags, RETI will not be able to clear this interrupt flags because source of interrupt is unknown. Source of interrupt is unknown. You got my point here? It might be TI or it can be TI or it can be RI. We don't know 100% which has raised this interrupt. So it cannot clear that part. As source of interrupt is unknown. Hence, we have to clear TI or RI, TI/RI using instruction CLR TI/RI. CLR TI/RI in ISR. In ISR. In interrupt service routine, you have to clear this flag, mandatory. With this, if you have understood this, there is no doubt. With this, we have cleared, finished unit number 4. But there is one small topic which I feel it is very important. Okay, there are some more topics. These small topics are there. Interrupt, listen to this. Interrupt can also be raised by force. Though you are not transferring any data, though your timer overflow is not done or not happened, you can go and set the timer flag. You are understanding this? So though the situation that like timer is not overflowing, you can by default force it to say that like it is overflowing. Understanding? This is possible. So please write. Set by, bits can also be set by an instruction. Set by an instruction. Example. Set bit TF0. Set bit TF interrupt. TI flag you can only set it. PC will directly go to 0023 directly. Right? Next one. Interrupt within an interrupt. Next point is interrupt within an interrupt. When interrupt occurs within an interrupt, let's see here. This is my main program. When an interrupt occurs somewhere in this, I will go to serve that. This is my service, interrupt service routine. When it is serving this one occurs, it will go to serve that. This is interrupt service routine 2. Then again one more interrupt occurs, it will go to serve that. This is interrupt service routine 3. This is called interrupt within an interrupt. There is another interrupt rises. When you are serving another interrupt, there is another interrupt rises. This is accepted only and only if this interrupt service routine is highest priority interrupt than this interrupt service. For example, this service is for INT1. Let's say its service is for INT1. Then this is for timer flag 0. Then this is for INT. Whenever this interrupt rises, first time, guys listen, you are running a main program. This is main program. When you are running a main program, if interrupt 1 rises, it goes and serves this. Serve this means like it will go to a particular location and then execute the code. When it is executing from timer flag, interrupt 1, serving this, if interrupt 0 flags arise, then like it will go and serve this interrupt service routine. In that case, RETI, when it returns, right, it returns to this interrupt. When it is doing this RETI will return to this RETI will return to main. Because it is loop within a loop. Dream, inception, last scene, same thing. Same here. Is it clear? Now the question, if not, if this is interrupt 0, what happens? It will finish this, it will not take this. Though it is rises, it will say like, hold on, highest priority interrupt is running. Highest priority interrupt is running. Once priority, the interrupt priority is according to the IVT table order by default, right? But you can also change this using a register called as an IP register. You can also change that by using a register. Just mention it. Though it is not there in your syllabus, it is for your information. They are not particularly meant for interrupt